Okay, good evening everyone. So today I will present about aircraft electrical systems. Okay, so there are five contents we'll be present in this session, which are introduction to electrical systems, primary power source of airplane, secondary power conversion equipment, power distribution systems, and lastly, emergency power sources. Alright, so aircraft are not possible to generate electricity from the ground, so it is important to have an electrical system throughout the aircraft. So the primary function of an aircraft electrical system is to generate, distribute electrical power, and store electrical energy for flight instruments, communication systems, lights, and electrical starter in aircraft. So there are three types of power sources in aircraft, which are the primary power source, secondary power source, and emergency power sources. Okay, so let's move first to the primary power sources, which is the equipment that generates electrical power by themselves. Okay, so the first one is the generator. Okay, generator is the machine that converts mechanical energy into electrical energy by the process of electromagnetic induction. Okay, whereby it uses the engine's rotational power to spin magnets mounted within a field coil, which produces electricity. Okay, so generators supply electric current to the electrical system while maintaining a sufficient electrical charge in the battery. So generally, all generators produce alternating current, but the method which is used to take current from the coil will determine if the generator provides alternating current or DC current. So generally, if a commutator is used in the generator, it will be a DC generator. Otherwise, if a slip ring is used, it will be an AC generator. Okay, so there are two types of generators. Like I said just now, the first one is the AC generator. So AC current is produced by AC generator, which is usually called alternator. Okay, so AC generator will use slip rings to provide the current to the circuits. Okay, alternator standard aircraft voltage is 115 volt with 400 hertz of frequency. So it is also usually used in larger applications in aircraft. Okay, so the second one is DC generator. DC current is produced by DC generator by using commutator. Okay, DC generator is designed to supply constant voltage that is usually have a 28 voltage and will supply current up to 400 ampere, and it usually used in smaller applications like battery. Okay, so generally, generator will produce AC current by using slip rings here. But when there is a commutator, okay, it will change the direction of the AC current to become linear, to become only flow in one direction, which is a direct current. Okay. The second one is auxiliary power unit, which is known as APU. So APU is a small jet engine which is normally located in the tail cone of the aircraft that serves as an additional energy source to start the engines on an airline. Okay, so APU have an extra electrical generator to create enough power to operate on board lighting and cockpit avionics, usually while the aircraft is parked at the gate. So APU is shut down before takeoff and reignited after landing, but APU can be also used as an electrical power source during flight. Okay, when the generator fails to produce a sufficient amount of power, the APU will provide additional electrical power to the airplane's electrical devices and systems. So APU serves as a backup source of electrical power. So far, do you understand? Do you have any questions?
No. Thank you.
Okay, so if there's no question, I will proceed to the secondary power sources. So a secondary power source is equipment that transforms and converts source power to supply electrical power to either AC or DC powered equipment. Okay, so most aircraft have the facility to be connected to a secondary power source that is provided during servicing or maintenance on the ground. So by using secondary power sources, it allows systems to be operated without having to start the engines or use the battery. So there are some equipments that only use DC current, like computers, lights, and instruments. So they need to change the current to make the maintenance or servicing effectively. So in order to convert the types of current, we will need a secondary power conversion like rectifier and inverter. Inverters will use to convert DC current to AC current and the other way for rectifier. Okay, so inverters does not produce any power as it get the input current from the battery and convert DC current into AC current. Inverter device's role is actually to control the voltage and frequency of the power supply to become higher and change the rotation speed of motors used in aircraft. Okay, this actually will change the direction of current from one direction to reverse direction, which call as sine waves. Okay, so there are two types of inverters, but the commonly used in aircraft is static inverter, which is smaller, higher efficiency, lower maintenance, and much lighter than rotary inverter, which known as inductor. So static inverters are located in an electrical equipment bay below the fuselage near the wings. Okay, so the second one is transformer rectifier. Okay, rectifier is an electrical device that converts AC current to DC current, which flows in only one direction. Okay, rectifier are often used to charge batteries from AC generators. So the process of converting AC to DC is known as rectification process as it straightens the directions of current, so the sine wave will become linear wave. Okay, so the second one is transformer. Transformer also is an electrical device that can be used to increase or decrease the voltage of AC current. Okay, this only works with AC current. If the secondary coil has fewer windings than the primary, then the voltage is reduced and vice versa. Okay, so far do you understand?
Shahidah,
Yeah,
the secondary power is not going to be used during flight, is it?
yeah,
So it's going to be used during service and maintenance only.
yeah.
Oh, okay.
But actually, inverter and rectifier also used during flight because there is a different current produced, right? So they need a rectifier and inverter to convert the current to supply to the equipments to other instruments during flight. Okay,
Okay, thank you.
all right. So we move to power distribution systems. Okay, so an electrical bus is used as a terminal in the aircraft electrical system to connect the main electrical system to the equipment using electricity as a source of power. So the main function of electrical bus is to distribute the electrical power to the lights, electrical starter, flight instruments, radios, or communication systems in aircraft. Okay, electrical bus is simplified as a wiring system and provides a common point from which voltage can be distributed throughout the system. Okay, so there are two types which are AC bus and DC bus, which will distribute AC current and DC current respectively as needed. Okay, the last one is emergency power systems. So in case of generators and APU fail, okay, emergency generators will install at some aircraft, which known as ram air turbine or RAT, to provide continuous power during flight. RAT is a small turbine that is installed in an aircraft and used as an emergency electrical power source when generators and APU fail. Okay, so RAT is rarely seen because It is an air-driven device that is stored in the wing or fuselage and deployed when aircraft loses normal power. Okay, RAT typically comprises a two-bladed fan. Okay, when deployed, it derives energy from the airflow due to the speed of the aircraft. So if the aircraft speeds are low, the RAT also will produce less power. Okay, emergency generator have AC output distributed by AC bus, then to rectifier to DC bus to supply DC output. Okay, the last one is the battery. So if there is failure on a RAM A turbine, okay, power must be taken from battery. A battery is a device that converts chemical energy into electrical energy. Okay, it is a power source that stores energy in a chemical form and recharged by generator. So it is used to provide power when no other power source is available and to provide a short-term source during emergency condition. Okay, so battery have less power than RAM a turbine, so the power distributed is limited only to some critical systems. So battery is the last power source of electrical systems and can only operate for maximum 20 minutes during flight. Okay, so that's all. Do you have any questions?
Oh yes, I have a question about the battery.
Okay.
Just now you said that the rectifier can convert AC to DC current, right?
Yeah.
And battery. So is this battery can be recharged by using rectifier?
Or cannot because battery is only can be recharged by generator. The rectifier, the function of rectifier is only to change the types of current.
Oh,
Okay?
okay. So it's not going to charge the battery, is it?
Yeah. Okay.
Okay. Thank you.
Hello, Shahidah.
Hello,
Okay.
Ryan.
Can you go back to the RAT, RAM air
Mm-hmm.
turbine?
Okay.
Okay, so it says here that RAT acts as the emergency electrical
Yes.
power when generators in APU fail. So I want to ask, does this RAT RAM air turbine powers all of the systems in their plane that needs electrical power? Since
Mm-mm.
okay,
Mm-mm. Yeah, it generator and FPU is still can operate, so the RAM air turbine will not be deployed. Okay, because it is located here. It only deploy when needed during emergency condition.
okay,
Okay.
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 Shaida, I have question about the PU.
Mm-mm.
So, as you
APU.
know, there are two types of APU in aircraft, which is the APU starter and APU bleed air. So, is it the same function?
Mm, actually, I am not really sure for that two types because starter is as I'm based on my understanding, starter is used to start the engine, right? The bleed air is used in cooling or heating system. So, uh, but during using of this APU system, it it also hmm,
I will answer the question. Any other question?
okay.
Any other question? Okay. Oh, aircraft on ground. Where do we get how? Where do you get the first power from? AC, DC.
Sorry, sir.
Aircraft parked on ground.
Mm-mm.
Where do you get the DC power?
Um, I think they get the DC power from battery, but the current will change to AC by using inverter. Is
Anybody
it
else?
correct, sir?
On aircraft parked on ground. Where do you get the DC power? Anybody?
Is it from external generator?
Yeah. Yeah. Here got one missing. Here is GPU.
GPU, ground power unit.
Yep.
Mm.
Yeah.
I think I didn't include it because I think that is complex, not the basic for electrical. Okay, so I will include that.
That's why
Right.
it's very simple, but at least you explain all the power. Right? When
Mm-mm.
aircraft parked on ground, first thing before we get the power to start the APU, there must
Mm.
be a power source. So either the power source come from the battery or ground power unit. Ground power
Okay.
unit is the external power mobile card that give you electrical power, DC or an AC. And also some of the ground power unit give you a big source for the aircon. Right?
Mm.
So for the on ground, you go to aircraft, you on the battery switch. Right? When you on the battery switch, then you connect your ground power, you connect the ground power switch to so the battery won't be used. But main thing is battery must be introduced first before you can introduce connect any power. So you
Mm.
select the battery switch and then after that connect the ground power, select the ground power. If you don't have the ground power, then the next thing is you start the APU, which is a auxiliary power unit. Auxiliary power unit is a small turbine engine. Right? So you use the DC to start the battery power to start the engine with the electrical starter. Once the APU is start, then you will run a generator which gives you DC power and AC power. Depends the type of generator installed on the APU. Now, to come to you, APU is a small turbine engine, auxiliary power unit. So it depends if you want, it also give you bleed air to start the engine. Engine depends on what type of air starter the engine is installed. Either is a DC starter, generator starter, or a air starter. Air starter use bleed to start. Right? Generator starter use DC to start. Is that clear?
Yes, sir.
Yeah. That is the main thing. Once the APU is start, power is start, and then you will introduce your DC and AC. After that, you do all your boarding and aircraft ready to push back. Then you start the engine. Installed on the engine, also there's a generator. So the generator will give you the AC power and the DC power. Depending on, normally there's two generators there. One to give you AC, one to give you DC power. So you supply all the power for the aircraft, AC and DC. Alright. There's one question asked how you charge your battery. So inside the aircraft, there's a box called battery charger. So every time, once there's electrical power, you go to the electrical charger and charge your battery to ensure that your battery is always charged fully. So in case of emergency, total loss of electrical power, this means there's no power from your generator, either from your engine or from your IPU. You can use the battery to last for 20 minutes. And this battery power only supplied to critical system only. That means only one side, normally the captain instrument. Okay, then come in the transformer and rectifier. Transformer and inverter. This is used only when there's a total failure of either DC or AC. Right? If your AC is failed, that means you need a static inverter to convert to DC to AC to supply some of the critical item, instrument or system. Same goes for if your AC failure transformer to convert terbalik ni. If there's a AC failure, you need a static inverter. If there's a DC failure, DC bus failure, then you need a transformer to convert AC to DC power to power your instrument. So this transformer and static inverter is a backup system, which is hardly used. It's just there for standby. Normally, every engine you got generator, APU you got generator. So there's plenty of generator inside the aircraft when it's flying. Okay. Any other question?
So I have a question.
Go ahead.
So if the aircraft take off during rainy condition and suddenly the lightning strike the aircraft, so is it will affect the electrical of the aircraft system?
Depends on your boarding of the aircraft and aircraft discharge. Lightning discharge. The lightning, when you start the aircraft, you will discharge outside the static energy will discharge through the static or electrical discharger, which is at the wingtip of the aircraft or at India once touchdown. You will not store on the aircraft itself. That's why the aircraft is fully bonded.
Oh, okay, sir.
Yeah. Only a very major lightning that will cause trouble, but it won't disrupt the electrical system. If it disrupts, then you got your battery to perform all the other things. It's very hard to short circuit on aircraft because there are multiple redundancy or circuit breaker inside. Right? Current limiter, all these things are put in place.
Oh, okay, sir.
Any other question?
So,
Yep.
so
Right.
during the flight, the aircraft will be fully powered by the generator.
Yep.
Oh, okay. So sampai landing lah, sir.
Yeah, once your engine is running, the generator is turning. It's just a matter you select on or off only, the power.
Okay.
Yeah. For an aircraft, it's normally on. So there will be a lot of circuit breaker. Like once your APU is running, once the engine is started, and your electric generator from your engine give enough power, you will trip the APU supply. This means only your engine will supply the 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 DC power and AC power. And for the aircraft, normally there's two engines. Partially some of the system will be supplied by number one engine generator, and the other half will be supplied by number two generator system. That means number two engine. So in case of one engine fail, the other engine still can supply partially all the instrument or system.
Oh, so only partial of this electrical instruments yang akan on lah kalau macam satu je yang hidup.
Yeah. That's when you partially, then you can select a cross fit. That means using only one generator to supply both. You have to select.
Okay, sir.
Once ideally two generator, two engine running, they will split the amount of power partially. Once one failure, you have to select to get from one generator only. The issue share the load, but one generator is enough to supply all the power, electrical power to the aircraft.
Alright, sir. Thank you, sir.
That's why when you go inside the aircraft, you can tengok movie, you can listen, you see all the lighting there. It's all from generator from APU. Right? Anything else? There's one sentence on the APU that, okay, APU also can start in the air. Right? Normally they will leave the APU on, and after engine start, they will put the APU, leave the APU on until they take off. Until they reach a certain flight, they will switch off the APU. During approach, some will also start the APU first before they land. So once they land, they have the APU ready. But it all depends on the operator preference. You just add up as a backup. That's why when aircraft on ground, if the APU is not running or inoperative, normally they will use ground power unit, GPU, to supply all this electrical power and big.
Sir, I have okay. Okay, dah boleh teruskan.
No, it's okay. It's okay. You go first.
Okay, sir, I have question about the IPO.
Sure.
So, if the pilot do the emergency landing, which is both of the aircraft engine is fail, so the pilots will automatically on the FPO. So during the aircraft land at the runway,
Yep.
I noticed that the spoilers will not be deployed. So is it because of the FPO?
Spoiler not deployed.
Yeah, spoilers will not be deployed if both engine is fail.
Both engine fail.
Yeah.
Okay. That one depends on the design of the aircraft. Different aircraft, different priorities. Because mainly once you lost both your engine, that is very crucial, critical already. So you want your power to be used for emergency system only. That's mean your
Oh,
landing gears, your flight, your priority, your flight controls, your instrument, all these things,
yeah.
right? So those not the priority for aircraft safety. They will normally they will normally not energize it.
Oh,
Yeah. Because once two engine failure, there will be there are a lot of checklists the pilot have to do to own which one is the priority one. They have a checklist. Right? If your APU also not available, that means your REC A system come in to give you the emergency electrical supply or your battery to give you a basic instrument to land. That means your landing gear must have. Right? That is a must. Sometimes with both your engine running, also you can. If sometimes you don't have your, if your generator fail, you don't have a electrical power. That's why there's a APU. That's why there's a ray and turbine and battery. It's not necessary your both engine has to be fail. Right? Your once your generator fail, you fail you don't have your electrical supply from the generator. So you have to get from other source like your battery, APU, your RAM A turbine, all these things.
oh. Okay, sir.
Yeah. Nazrul, try not to imagine both engine fail. Right?
Okay, sir.
Right? It's very difficult to get both engine fail.
Okay, sir.
Right? Very difficult. One engine, yes, but both engine very susah. Mau mau strike lottery pun senang lagi than to get both engine fail.
So, how about I noticed that the pilot can also use the ILS system, which is the aircraft can do auto land. So, if both engine failure and there's only APU source, so the APU source also cannot back up the ILS, isn't it, sir?
Okay, iOS is a other instrument. It's an autopilot instrument, right? As long there's a power, the iOS is just a reading from the ground to capture something from the ground, right? It's an instrument, right? So if your APU is running, and your engine is running, you can have your IRS, your gyroscope. Mm. Unless you have your battery only, then you don't have it. Right? Battery only standby instrument or on.
Oh, okay, sir.
Here we are talking about electrical failure, not engine failure. That's why if your DC fail, that means you have your transformer to change AC to DC. That's when the transformer come in, or your static inverter come in if you have AC failure. That means your AC bus failure. Okay, Afida?
Oh, yes, sir. I actually wanted to ask for the RAM turbine. It seems like there's a propeller, small propeller in there, right? So the propeller is like retractable or how,
Yeah,
sir?
it's a retractable, right? It's
It is
stored
retractable.
inside the belly, inside the aircraft. Not every aircraft have it,
Okay.
right? Normally, very wide body aircraft only have it, right? It's stored and it will deploy. If we need it, we will deploy. That's when you see the bottom picture there, you will
Yeah.
store inside the fuselage or under the wing, right?
So it will be used if the APU is failed or how, sir?
It's, everything fail. All your generator fail.
Oh, okay. So this
Yeah.
one is the last resort lah.
Yep. Then before you go to your battery, at least you have any additional source of electrical power. You use your RAM A turbine. Right? This one is just like your windmilling. You know the windmilling turbine that give you electrical power.
Yeah.
Same thing. You turn the wing will turn the propeller and will generate. It's just a DC motor lah. Yeah, that's what.
Okay. So this will help for them to like the instrument. Just certain instruments can be on lah kan sir. Sebab dia macam limited power. So basically this will help to blending
Yeah,
during
you will
emergency.
see some source of electrical power lah. Yeah.
Mm,
Because wide body you need your battery sometimes won't be enough because you are flying very high, right? So
because
at least you get sometimes for the electrical power. Instead of your battery only give 20 minutes, maybe you can charge the battery to give you another 10 minutes or 20 minutes. Okay, anything else?
so sir, the RAM air turbine ni kan, dia boleh support the air conditioning system also kat in the cabin because if I'm not mistaken, the air conditioning will help for pressurize the cabin, right sir? So
Yep.
if the APU is failed, right, will RAM air turbine will be able to help to stabilize the pressure in
Nope.
that? No.
This one only give you electric power, not
Oh,
no air, no air pressure. Mm. Your pressurization is mainly by the air, bleed air of the engine or APU,
oh,
the bleed source.
so it's APU and the main engine.
Yep. Anything else?
I think provided from you sir.
Sir,
Yep.
or
Go ahead.
if electrical power is lost, and the normal power is lost on the aircraft, to deploy the this R80, do it needs electrical power too, or it use hydraulic mechanism?
It's mainly just a switch to open the latch. Then the thing will drop down by its weight, by the weight of the turbine. It's just a simple latch, like a latch, actuator latch. We can use the battery power to unlatch it.
Oh, okay, okay.
Macam you punya kereta punya door lah, lock and unlock. Once it unlock, you will fall by gravity to deploy.
Oh, okay.
Anything else?
So one more thing. For the APU just now, since it is a small jet engine turbine,
Yeah.
is it just producing electricity? Does it so it does not produce any thrust force?
It produce minimum thrust because you don't have a big fan to give you the thrust. Maybe the exhaust come out will give you slight because of the exhaust pressure on it. You won't be able to move any thrust.
Oh, okay.
Because for engine, the main thrust come from the big fan or from the propeller in front of the engine.
Okay, sir.
Yeah. When we come into engine, you will see the difference.
Okay,
Where
sir.
is the thrust normally generated? Anything else?
Oh, sir.
Hello, sir.
Oh, yes.
Oh, okay, continue.
Sir,
Go, go ahead. But
Hafidah lah.
Okay, okay. So for the small aircraft with turboprop engine, right? Can
yeah.
the propeller act as a ram at the blind if it fell?
Huh?
I mean, like the turboprop engine kan dia ada propeller dia sendiri, right? So it
Yeah.
cannot act as a wind turbine ke to provide
No,
energy, no.
no.
I'm just curious about that one.
It's not a motor.
Oh, okay.
Yeah.
So the propeller is actually moved by the generator engine. Okay.
Yeah. Later you see the engine, you know how the propeller turns. Right?
Alright, sir.
Yeah. It's not connected to anything.
Yeah, I thought it was connected to the motor, so maybe it can generate because it has propeller in that, right?
Yeah. No.
Yeah. Okay, sir. Thank you, sir.
Evelyn?
Okay, hello, sir. During flight, the generator and the APU is not used simultaneously, yes, sir. The generator used.
The generator. Normally, the aircraft will use
Only
once engine started, they will use engine generator. The APU generator is for standby. You automatic cut off if both the generator is online. Right? When you start number one,
okay, sir.
the thing number one will power half of the aircraft electrical system. APU will power the other half. Once you start number two engine, then number one and number two engine will power the whole aircraft, half half. Then the APU is just sitting there, cut off. In case there's any failure, the relay will come connect it online.
Okay, sir.
Okay. Next two.
Okay, so that's all from me. We'll pass to the
Uh,
next presenter.
Yeah, go
so
ahead.
I have last question, sir.
Go ahead. Go ahead.
Okay.
So example, if the FPU is damaged, so it means the aircraft engine cannot be start, isn't it, sir?
What's the question?
If the FPU system is damaged, so the aircraft engine also cannot be start, isn't it, sir?
APU. Okay, APU is unserviceable. All right.
Okay.
Engine cannot be start.
Yeah.
Depends when you are. If on ground, that's why I say there's a ground power unit for you to start or a start your engine. Either your engine using the bleed or using the DC starter to start the engine. If
Okay, sir.
if is in air, if one of the engine flame out, you want to start the engine again, then
Yeah.
you use the other engine to start. You go there, your bleed and your electrical power.
Oh.
Yeah, that's why they have both engine. One, if one fail, the other one will help to start.
Oh. Okay, sir.
Yeah. Okay, next. Oh, we try to get some of it.
Okay, so with that. Hello. Can you see this slide?
Yes.
Okay. Thank you. Okay, so hello everyone. So now I will be presenting about the aircraft fuel system. So Aircraft fuel system is designed to allow the fuel to be loaded, stored, managed, and delivered to the propulsion of the aircraft, or another term, engines of the aircraft. So a little information here. So what are the types of fuel commonly used in the aircraft? For the typical aircraft used by the military or commercial purpose, the fuel used is the kerosene-based fuel. In the kerosene-based fuel, some products are usually added to prevent corrosion and freezing, such as antifreeze, hydrocarbon, metal deactivator, antioxidant, and etc. So next, where are the fuel tanks are located? So mainly, the fuel tanks are located in the wings of the aircraft. If we can see the picture below, the main tanks here are located at the wings and not at the center. Center tank depends on the types and design of the aircraft. Some airplanes have center tanks equipped, while others only have main tanks located at both wings. So aircraft wing have hollow structure inside, which allows the storage for fuel storage. Uh, in other words, these wings that can store fuel are also known as wet wings. Okay, so next. So, why does the fuel tanks are located in the wings? So there are three main reasons as to why the fuel tanks are located in the wings. The first is to improve the structural efficiency. During flight, the wings are subjected to high bending stress uh, generated by the lift force and also during maneuvering of the aircraft. So, fuel tanks may, by adding fuel tanks to the wings, it may add a bit more weight to the wings that may help to reduce the excessive bending stress that may cause the structural damage. Because when we let the structure inside the wings empty, the high bending stress will cause excessive excessive strain to the wings, which in turn may cause permanent structural damage. So by adding fuel inside the wings, uh, we can, in other words, add a little bit of density to strengthen the wings to reduce the bending effect. Okay, second is to reduce the system complexity. So as we all know, engines are located at the wings. So by placing the fuel tanks above the engine, the distance for fuel transferring can be lessened, and so does the length of the overall pipeline. Besides, it will also be much easier for gravity feed operation since engines are located under the wings. Okay, next. The third reason is to improve the safety. The main point here is the fuel tanks are located at the wings far away from the passenger to reduce the risk of fire accident to passenger by placing the fuel away from the passenger. So in case any fire accident occurs, uh, yeah, the accident will occur a bit further from the passengers and not reduce the risk of harming the passengers. Okay, so next, okay, this is the general basic components of the aircraft fuel system. This is the components that usually every aircraft fuel system have. The first is the fuel tanks. As we all know, the fuel tanks are used to store fuel and manage the flow. Okay, there are two kinds of tanks, which is the storage and for engine feed. Actually, engine feed and storage, we can say they are uh, the same tanks, but are separated a little. So the next components are fuel lines and fittings. Fuel lines and fittings are the means for fuel transportation along the system. Usually fuel lines and fittings are designed to be able to withstand the high temperature and prevent the vibration from fuel pressure. This is because fuel always flowing, so sometimes it may cause vibration due to the pressure surging or pressure spikes, something like that. And the third one is the fuel valves. Fuel valves are usually used for shutting off the flow, for selecting the flow from which tank to which engine, and then for closed fit application and also for direct fuel transfer. The fourth one is the fuel pumps, and the main function of the fuel pumps is to provide the constant flow of fuel regardless of the altitude. It means although the plane is flying at different altitude, the fuel pumps are designed to be able to provide constant flow rate to the engine. Next is the fuel filters. As the name implies, filters are used to prevent foreign matter from entering the engine and trapping small amount of water that may be present. This is to prevent the damage to the engine structure and pump structure. The last one is the fuel gauges. This is we can say that it provides indication uh, to provide information that indicates the level of fuel that contains in the fuel tank. Okay, so before we look into much more detailed information about the fuel system, we will first try to look into a simple overview of the fuel system of general aircraft. Okay, so first, fuel system are
Okay, before
consist.
you go into there,
Okay,
for your info,
yeah.
later this week, you guys will be going to see how they change the fuel cell in the Twin Otter. That's meaning the Viking, right? They will be doing the painting almost finished. So you guys will go to the hangar and see them do the replacement of the fuel cell. For Viking, the Twin Otter, the fuel cell is at the belly of the aircraft. Mm. So there's a difference between the small aircraft and a big aircraft. Big aircraft have a bigger wing, so they need the. That's why the fuel is put on the wing, as stated by Ryan there on the slide number 2. Why they want to put on the wing. But for smaller aircraft, normally they was small. The wing is very small. They only use at they'll put the tank at the belly of the aircraft. This means they will separate it forward tank and aft tank. Forward the fuselage, below the cabin seat. When you visit the aircraft, you will see how the tank is assembled. Okay.
Oh, okay, sir. So sir, does that mean the smaller aircraft they don't have any fuel tanks inside the wings for some small aircraft,
Nope.
or even though
Normally
they
they
use the twin engine?
yep. Normally
Oh,
they will put on the belly
oh, okay, 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 sir.
because they don't fly high. There's no stress on the aircraft wing. Yeah.
Oh, okay, okay.
Yeah. Normally smaller aircraft they fly less than 10,000 because they also don't have they are not pressurized. So not pressurized that means normal people cannot go above 10,000 feet because of the lack of oxygen.
Oh, okay, sir. So I continue.
simple overview berapa slide?
Apa sih? About 4, 5, something like that.
See, just overview of the aircraft system.
Okay.
Right.
Okay, sir. So for the fuel system of the aircraft, first it mainly consists of course, it consists of fuel tanks, which is interconnected. It's a there are wing tanks, wing main tanks, and also the center tank, which is located at the fuselage. They are interconnected by the pipelines. Like you said just now, some aircraft have a main wing tank and also the center tank, while some o- only use the center tank, or maybe some only use the main wing tanks. Uh, so they are all interconnected to allow the smooth or transfer of fuel. Okay, next, pumps is installed in the system. As we all know, the pumps is used to provide the constant flow rate of the fuel flow. Uh, it in uh, Pumps also increase the fuel pressure before it is sent to the engine for combustion. Why it is increase the pressure? Because as pressure increase, the temperature also increase. That is that is quite important for the combustion aspect. Okay, next. Okay, beside pumps, filters are also installed in the fuel system, as we all know, mainly to prevent the remove impurities, prevent the foreign metals from entering the system, damaging the structure. And next, there are also fuel oil heat exchanger installed in the system. Um, so before the fuel flow into the combustion chamber, it passes through the heat exchanger. This is done for preheating process, which is reducing the oil temperature and also increase the fuel temperature. Oil and fuel here are different things. Oil here refers to the some sort of lubrication oil inside the engine, while the fuel here fuel for combustion. As the oil resides in the engine, it lubricates the engine, but at the same time, as engine running, it also absorbs the heat from the engine, so it becomes hot. The temperature increase. But the fuel is located in the tank. It is not directly connected to the engine, so the temperature is not that high. So to increase the temperature of the fuel, it is direct before it enters the combustion chamber. It is directed into the fuel oil heat exchanger, where the heat from the oil will be transferred to the lower temperature of fuel. This will lower the temperature of the oil and also increase the temperature of the fuel for better efficiency for combustion. So next, crossfit valve. This is one of the most important components in the aircraft fuel system because crossfit valve in connected between both tanks on the of the wings. It is essential for inter-tank fuel transfer, mainly during engine failure or pump failure. In case of, for example, left pump failure, it cannot pump the engine towards it cannot pump the fuel towards the left engine. So the by opening the crossfit valve, it allows for the pumps at the right to pump the fuel to the right and left engine to provide enough fuel flow. Okay, so next is the in case of failure on both wings of the aircraft, failure of the pumps, where the fuel cannot be pumped. So what they use here is they use the gravity feed pump method. It is a small pump that provides fuel to the engine through gravity. As we all know, the engine is usually located under the wings, so this also helps with the gravity feed system. Usually, when this sort of problem occurs, where the uh, fuel cannot be feed into the engine optimum flow, the airplane will fly at lower altitude to help to increase the pressure inside the tank so as to help for more flow for gravity feed. Okay, so next, refuel and defuel line. So it is basically this line is used to fill the tanks with the fuel and also to remove fuel from the tanks. Next is the vent tanks and surge tanks. This is also part of the tanks of the fuel, but usually vent tanks is not filled with any fuel. Because vent tanks is used to stabilize the pressure by letting the air into the tanks. Besides that, it is also used to as additional space to allow for fuel expansion due to temperature variation. As the temperature increase, uh, the fuel may also expand, so may cause some spilling. So in case of spilling occur, it will flow into the vent tanks, which is empty space there. Besides that, vent tanks also can be used to absorb pressure surge from the fuel. Okay, last, the flight cockpit. It, there are indicators provided in the flight cockpit to show the quantity of the fuel, temperature of the fuel, pump operation status, and also closed feed valve position. This is all indicated at the flight cockpit and can be controlled through the control panels also located in the cockpit. Carry on, sir.
I think this will be stop. Any question? Right, you just go through the slide slowly. I want to see what slide.
Okay.
Some more. Okay, some more.
This is much more, for me, it's a bit more detailed compared to
Okay,
before.
some more.
Before just overview, this is more detailed information.
Some more. Okay. This is what I want.
Okay, that's all.
Okay, go back to the time you stopped there just now, the
You
earlier
want
one.
me stop? Okay.
What is it? How fuel system work? The next one. Next one. This one is what? Fuel system. Equalize the ambient air.
Yeah.
The next one. Next one. Next one. This one you were talking too much on the system, the vent surge tank already. Next one. Filters. No, next one. Shut off, shut off. Wow. Next one. Next one. Next one. This what I normally you guys just explain lah, right? Ryan?
Okay.
Yeah. So you start with this, like tomorrow you just start with this, right?
Okay. So
And then
directly go
explain,
at this lah.
explain how where is the refueling, where is the fuel going, right?
Okay.
Yeah. And tank one, tank two, and where does if the pump running, where does it supply, how it supplies to the engine, right?
Okay.
That's the main thing. Normally, try to do a schematic diagram like this, and you explain the system, how the system flow.
Okay, sir.
Because yours one later on you are talking more on the float switch, the float valve, the thing. But the main thing is how the system flow.
Okay.
Explain that one, then only go to certain area that how the pump, what is the pump function, all these things. But
Okay.
overall, this is the type that you guys, if you ask to do a system, this is the type that you guys go in normally, right? Hydraulic pressure, where is the hydraulic line used to? Like here, you can see the pumps, the filter, the check valve, the line, refueling line, defueling line, crossfeed valve, shut-off valve, all here, right?
Okay, sir.
So when you explain, then you know how the fuel start from the bowser, go into the tank, from the tank, how it reach to the, from left-hand tank or right-hand tank, it goes to the engine. Okay?
Okay. Okay, sir.
Okay.
Can.
Tomorrow you start from here.
Okay. Okay,
Right.
sir. Boleh.
Before that, anybody have any question on the thing? Another question I want to ask. Normally, you guys give them to read in advance, or this is the first time they're showing?
Usually we just show it the first time during our presentation. Then after presentation, we give the reading materials to the group.
Oh, okay. Okay. Maybe you can give the reading material first.
Okay.
Then tomorrow will be easier, right?
Okay, sir.
Those who present anything, try to give the reading material early so they can read through and the question already there, right?
Okay.
So they'll get ready the question. If not, it's very hard to digest and then ask question.
Yeah.
Okay.
All right, sir.
All right. Okay. See you guys tomorrow.
Okay, sir.
All right, sir. Thank
And
you, sir.
tomorrow I'll
Thank you,
arrange.
sir.
Tomorrow I'll arrange when you guys coming to go into the hangar.
Okay, sir.
Sir,
Yep.
I have a question regarding the hanger. So, do we need to wear safety shoes when entering the hanger?
No. You
No.
went there and have a look only. Do you have a safety shoe?
No.
Yeah.
Okay,
Because
sir.
you are not working there, and
Yeah.
you are observing.
Okay, sir. Thank you.
Normally they won't let you guys work on anything unless you guys have some background on how to remove a pump, remove a switch or something. If not, they won't let you touch anything. You just observe what they do and ask questions.
Okay, sir.
Yeah. Okay.
The
Kak,
left.
Okay, sudah left.
so esok kita turun kan?
Esok dia bagi tahu. Kan?
Oh, okay.
Macam dia cap gitulah, esok dia bagi tahu dia cap.
Ya, besok saya beritahu.
Okay.
Okay.
Okay, kalau macam tu ada apa-apa lagi?
Okay, dah sudah.
Okay, see you tomorrow.
Okay, bye-bye.
Okay, bye.
Okay. Bye.
Bye guys.